Good afternoon, morning, evening, whatever time it is, and welcome to our video progress report for Aegis, Team 43. We're excited to talk about some of the work that we've been doing over since winter break, and one of the big parts is that we've changed our solution progress. Based on our research last semester, our intention was to create a solution for radiation hardening by process. However, based on financial, time, and location constraints, Aegis has shifted to a radiation hardening by design solution instead. This transition entails Aegis now working to design error correction code that will read data, identify errors, locate bit changes, and fix the data to the correct value. This decision was made in conjunction with our partners and advisors at Moog Broadreach.
One of the changes that we have made for this semester to be a little more efficient and get more of our goals done is our meeting frequency wasn't as high as we would have liked to it have been last semester. So one of the things we have done to amend that this semester is have a specific date every month that we will meet with our contact Chris from Moog, as well as specific goals that we have in mind that we would like to meet every time we meet with Chris, so that we can ensure that we stay on track.
As of this semester, our team has been working to develop the Reed-Solomon error correction code in Verilog. This Tuesday, we hopefully will be presenting our Reed-Solomon encoding solution to the Moog engineering team, Mr. Chris Hodge and Gates West. In the upcoming weeks, we plan on presenting them our Reed-Solomon error correction code as a whole, which includes the decoding process, which we have yet to develop.
So for the code that we've written so far, Reed-Solomon error correction relies heavily on Galois field operations. So most of the code we've written just involves operating on these Galois field numbers, so multiplication, division, etc. And then we've recently completed almost all of the polynomial operations, which will allow us to encode a message. So this week we're hoping to encode a message, and then the remainder of our time will be working on fixing errors in these messages.
The section of code that I am currently working on is the Reed-Solomon generator polynomial code. The main purpose for this code is to generate an irreducible polynomial, and this section of code is going to be used later on in the error correction code. And the other section of code that I will be working on with the assistance of Demi is the Reed-Solomon error locator code. And this code will be used to locate any errors that are in the message that we are going to be testing.
So the part of code that I'm currently working on is the divide polynomial code, which will divide two Galois field polynomials, the remainder of which will be the parity bits, which are tacked on to the end of a message, which will enable us to do our error correction.
So the section of code that I will be working on will be the two functions, the RS encode message, which is self-explanatory, and the calc syndrome function.
And like Ollie stated earlier, Ollie and I will be working in conjunction to find the error locators, identifying where the errors are in the bits, and basing it on that, where our error correction code will be able to run. I'm also creating the output correct message indicating whether the code needed to be changed based on an error, and if it did, where that error was.
So in conclusion, originally our project's goal was to do radiation hardening by process, but after a meeting with Moog, we were redirected down a different path towards a solution that they would prefer, which is radiation hardening by design. And so now currently we are all focusing on coding in Verilog to substantiate the solution that is required.